Hello ladies and gentlemen, in this video I will show the use of the serial communication library developed by Woodall and John Harrison to implement a C++ program that sends and receives data from an Arduino board. The board will echo every byte we send back to us. We start with an empty folder for our C++ program. I'm gonna call it CPP program. We can then open up the folder and clone the serial library Git repository. You can find the link to the repository in the description of this video or search for wjwwood/serial and you'll find it. After finishing cloning the repository, you should see a folder called serial inside our folder like this. I'm going to open up the project on Visual Studio Code. Next, we create a C++ file. I'm going to call it main.cpp. In it, you can enter the following code. Here we are importing string and IOStream headers because we will be using their functionality, and we also import the serial library we've just downloaded. The main function implements a C++ program that just returns 0. If you also see these errors when trying to import the libraries, you can go to Quick Fix and something about include path and change the clang to G++. Now everything should be okay. We can save it and go to the terminal and use this command to compile it. These warnings are from the serial library itself, so we'll ignore them and everything works. Next, we will enter this code. This code prints the available serial ports on the system. To do this, we call list ports from the serial library to get the available ports info. Then we use a loop to print each port's data. Again, we can save it and go to the terminal, compile it, and we can also run to see the ports we've got. You may see many ports. If you're not sure which port the Arduino is connected to, you can go to the Arduino IDE and see the port on the board selector and on the bottom right corner. In addition, the port info structure has other members which you can also print to get more information about each port, like the description and hardware ID. Knowing the Arduino port, we can then instantiate a serial object which will allow us to communicate with it. We do this with these two lines of code. The first one is creating and opening the serial communication, and the second one is closing it. The first argument in the first line is the Arduino port address, which is one of the strings printed when listing the ports. The second is the baud rate, which must match the baud rate specified when calling serial begin on the Arduino code. We'll see that later. The third is a timeout object, which specifies the read operation timeout in milliseconds. Here I'm building an object which specifies a timeout of 250 milliseconds. Let's save it, compile it, and test it. And it works fine so far. If you receive a device or resource busy exception, this is probably because you have the board connected to the Arduino IDE. You can then go on to the Arduino IDE and close the serial monitor tab, go back and try and run it again, and it should work. Now we add the following code. This code creates two strings which will act as buffers for sending and receiving data. We prompt the user to enter a line and store it on send buffer. We write send buffer to the serial port, sending its value to the Arduino. We then read from the serial port and store the value into receive buffer. Then we print the message we received from the Arduino. The argument on the read call is the amount of bytes we want to read. Note that I'm reading exactly the same number of bytes as we are sending. We can then save this, but before we compile and run the C++ program, we need to upload a code to the Arduino board. Open up the Arduino IDE and paste the following code. This program starts a serial communication with a baud rate of 9600. Remember that this value must be the same as the one we specified on the C++ program, right here. Inside the loop, we are waiting until we have at least one byte available on the serial communication. Then we read it and send it back. We then upload this code to the Arduino we are using. After it finishes, we can go back to the C++ program, compile it, and run. we can see it is asking for a message. We can type anything here and press enter to submit it. And then we can see that the Arduino sent the exactly same message back to us. And there we have it, a communication between a C++ program and an Arduino program using the serial library. As a bonus, you might have noticed that every time we compile with this command line, we see these serial warnings. This is because whenever we compile like this, we are compiling the serial library again and again. We can avoid this by compiling the library to object files. I'm going to go back to the project, create a Makefile here, and paste it in this content. It will also be available on the description of this video. This Makefile requires a objects folder, so I'm going to go ahead and create it here. With this file, we can compile the project by running the make command. And whenever we change the main.cpp file, running make again will no longer compile the library again, like this. By changing the baud rate, we can save the main file and run make again. And you see that we no longer got these serial warnings. That's because we already compiled the serial library and its objects are stored on the objects folder. And finally, by running make clean, we delete every generated file from the project folder. If you want to know more about Makefiles, check out the makefiletutorial.com website. This concludes this video. If you have any questions, suggestions or comments, feel free to post them in the comment section. Thank you for watching.